Everyone. So our goal for today is to calculate and differentiate distance, displacement, speed, and velocity. So if you look at this picture, I think it does a really good job of showing exactly what is distance and what is displacement. So we have a little green man, he walks along this path and he ends up over here. Starts here, ends here. Distance is the total length of the path. Displacement is how far you are from where you started. Now, distance has no direction to it. Notice how, the length of your path, you were constantly going different directions. It's just the total length of your path. It's just a number with a unit on it. Displacement, on the other hand, has a length. Okay, it has a magnitude, but it also has a direction. This is not just how far you are from where you started, it's in which direction. So number one says, before we move on, we need to make something clear. Distance and displacement are not the same thing, though we frequently use them interchangeably in our everyday lives. So distance is, as we just said, the total length of your path. Displacement is how far you are from where you started. And not just how far you are, but also in which direction. All right. So let's say you walk 8 meters forward, then 3 meters backward. So I'm going to start doing my distances in black. So let's say you did this. Let's say you walked 8 meters forward and then 3 meters backward. Well, the distance you traveled is 11 meters, the total length of your path. The displacement is how far you are from where you started. So this is where you ended. This is where you started. Draw an arrow from where you started to where you ended. 5 meters. So your displacement is 5 meters, but you need a direction. Well, we were 5 meters forward. Now let's say you walk 43 meters down the hallway. You make a sharp right turn and you walk another 18 meters. So let's draw it out. We walk 43. I'll draw it here. Make a right turn. We walk another 18. This is not to scale. From here to here, that's going to be our displacement. So our distance hopefully is pretty easy. It's just the total length of your path, 61 meters. The displacement, think for a second about how you can possibly find that length here. We're going to use Pythagorean theorem. 18 squared plus 43 squared equals c squared, or our resultant squared, whatever you want to call it. So let's throw that in our calculator. 18 squared plus 43 squared. We're going to take the square root. I'm getting 46.6 meters. But we also need a direction. Now, how can we find the direction? Let's get this angle right here. That's a good one to have, the angle with respect to, where you started. Now, how can we possibly get that angle? We're going to have to use some trig. We can use sine, cosine, or tangent. I'm going to use tangent, and here's why. Tangent utilizes the opposite side and the adjacent side. Those are my givens. Cosine and sine utilize the hypotenuse. Maybe I made a mistake there. That number's a little rounded, so we should use the givens whenever possible. So to find that angle, I'm going to write tangent of theta equals opposite, which is 18, over adjacent, which is 43. And then I'm going to do theta equals tan to the negative 1 of 18 over 43. All right, so let's see what we get there on our calculators. So 1 sec. I'm getting 22.7 degrees. So it would be that angle right in there. Now, what would I call that angle? Northeast, southeast. For now, just 22.7 degrees. We'll worry about the cardinal directions later. I didn't give you any here, so you can't really use them. So speed versus velocity. No, speed and velocity are not the same thing either, though we frequently use them interchangeably. So speed and velocity are both the rate of change of position, right, in both cases. Now, speed, direction does not matter, therefore it's always positive. Velocity, though, velocity is the rate of change of position, but direction does matter. You can have positive or negative velocity. All right, so let's write the equation out for velocity first. It looks something like this on your reference table. V, as a script V, with a bar over it, equals d over t. If you look on your reference table, it tells you that this V right here stands for average velocity. It says d here stands for distance or displacement. In this case, in the velocity formula, it stands for displacement. And t stands for time. Now this can be a little bit confusing, but your reference table does tell you this. The equation for speed is exactly the same. But why does it say v and not s? It's just the way we do it. But your reference table does mention that this is either average speed or average velocity. So this can be for average speed as well. D in this case, if you're looking for average speed, you use distance, not displacement. And t is time again. All right, so distance is a scalar, speed is a scalar, velocity is a vector, displacement is a vector, so they go together. This is a really good picture that illustrates speed versus velocity. One car is going right, one is going left. Both cars have the exact same speed because direction doesn't matter, 25 meters per second. The car going to the right has a positive velocity, the car going to the left has a negative velocity. So let's look back at problem 2 for a moment. If it took you 5 seconds to walk, what is your speed and what is your velocity? So I'm just going to put a line down the middle here. These are separated. Okay. So speed is distance over time. So V equals D over T. Now the distance for number 2 was 11 meters. Over 5 seconds, we get 2.2 meters per second. The velocity is displacement over time. That's going to be 5 meters over 5 seconds. Again, the displacement for number 2 was 5 meters right here. 5 meters forward. Don't forget to include that at the end. So our velocity is 1 meter per second forward. So let's look back at number 3 now. We're looking for speed and velocity if it took 22 seconds. So number 3, our distance traveled is 61 meters. So we have V equals D over T. Again, distance over time for speed. So 61 meters over 2.2 seconds, or excuse me, 22 seconds. We have 2.77 meters per second. Our velocity is going to be displacement over time. The displacement is going to be 46.6 meters. And the time is 22 seconds. 46.6 divided by 22. We get 2.1 meters per second. Okay, and the angle is 22.7 degrees. You should throw that in. So we're going to start talking about this vectors soon. So velocity and displacement are what we call vectors in physics. They have a magnitude and a direction. So they can be drawn using arrows. We'll get to that in later classes. Distance and speed are what we call scalars. They have a magnitude, but they don't have a direction. You can't really depict them simply by using arrows, okay? But we're going to talk a lot about vectors as the year goes on. We're going to kind of sprinkle it in here and there. We'll talk about it a lot at the beginning of the year, not as much as at the end. Here's an exit ticket if your class got to this. Not every class got to this. It says you walk 4 meters north, then 3 meters west in 10 seconds. Find the distance, displacements, velocity, and speed. So if you had done this one, even if you didn't, you should still check it out. This is 4 meters. This is 3 meters. These should be straight lines. Okay, so your distance right away, that's an easy one. You don't even have to really draw it out for that. That's 7 meters. Your displacement, you can use Pythagorean theorem or just recognize that this is a Pythagorean triple here. This is 5 meters. Again, how do you do that? 3 squared plus 4 squared, take the square root, you get 5. Now I should also get the angle here just for good measure, but I told you not to here. If you were going to though, you would just use the tangent function 3/4. Now to get our speed. Speed is going to be distance over time. So speed equals 7 meters over 10 seconds, 0.7 meters per second. Velocity is going to be displacement over time, 5 meters over 10 seconds, 0.5 meters per second. All right, so there we have it. That should have, velocity and displacement should have the same angle. Okay, but I didn't ask you for direction here, so you don't need to. But if you did, it would be the inverse tangent. I'll just write it out. Theta would have been the inverse tangent of 3/4. All right, let me know if you have any questions, and I hope you have a great day.